to actually have the workshops because tomorrow is like holiday, right? So yeah. Okay, let me share my screen. I think it should be okay. Let me just share entire screen. Okay, cool. So yep, let's begin now. So basically today we are going to cover ML.NET and .NET Web Services and how it actually connects both together. So I am Benedict. I'm your host today. I'm a Microsoft Learn Student Ambassador, and I'm going to present the content today by going through the slides first. So by providing some context on machine learning. So ML.NET is basically machine learning in .NET framework. And yeah, nowadays machine learning is everywhere, right? Like once you open uh, your Bing chat or like Copilot or even on GitHub, right? So it's basically everywhere, and the weather forecast on your phone. So yeah, there's a lot of use cases in machine learning nowadays. And this is just sharing like what is a machine learning problem, right? So just for context, this is just a story. So Kate, she wants to purchase a new smartphone, and she wanted to calculate how much she needs to save for purchasing a smartphone. So basically by this saying, right, for each of the smartphones, there are actually general aspects to consider, which are hardware, performance, design and size, years of production, and of course many more. But these are some of the aspects that need to consider to decide the price, whether Kate can purchase it or not. So here comes machine learning, where in this case, let me just draw it out. Of course, what machine learning can do is basically what human can do as well. So you can imagine like this, okay, right? Let's assume that Kate is taking the, what is it? Maybe hardware performance. So basically, okay, so this is hardware performance, okay. Sorry, my drawing is very bad, but yeah. So this has a performance, and the things that she wanted to know is actually the price, right? So price is at the y-axis and hardware performance is at the left axis. No, x-axis. So basically, if when it comes to like 4 core, right, 4 core, and it is definitely lower. Let's say it's like 1.2K MYR, right? So it will be here. And then let's say she's considering 16 core, okay? So 16 core, definitely price is going to be higher because the hardware aspect is higher. Let's say 5K. So the point will be here. So when it comes to the point of saying Kate wanted to decide like what price is the for the aspect that she want, but she doesn't have like a very specific model in mind yet. So with this being said, from time to time she did some research, like the 4 core is 1.2K, the 16 core is 5, and of course maybe let's put like 8 core, and let's assume 2.7. So the point will be here. So she actually can see a pattern of saying that for the cost that she's going higher, she actually needs to pay more. So she can imagine that, let's say she wanted to find for, I know it's not available out there in market, but 6 core. So she can imagine that the price is around here. So this is what basically machine learning works on. Specifically, this is actually supervised learning. So in machine learning, there are supervised learning, unsupervised learning, and reinforcement learning. And supervised learning is basically you are giving a context of saying, okay, I have a thing in mind that I wanted to predict. Okay, like for example, here you have price, and the aspect that you have is actually the hardware performance. And unsupervised learning, on the other hand, is you don't really have something in mind, but you have the data. So just for a context is when you are going to a supermarket, you know that there's a lot of products, but you don't know what is the categories available. So basically, you are feeding the machine saying that, hey, I have all of this data. You figure out a category for me according to that, and that's basically called clustering in unsupervised learning. And reinforcement learning, I know most of you should play games, so that's where reinforcement learning comes in. Basically, is they're training agents by understanding how the game works, like how much they can earn the most out of the game, meaning that how much they can score. Let's say you are playing Dota, so the highest KDA you are scoring means that you are getting better score. So the agent will go into the environment and train and learn out of it. So that's where it comes to the point that you have like easy difficulties and also medium difficulties and hard difficulties. So that's just some context on the theory part. But yeah, today we are going to look at the supervised learning only. So, okay, yeah, yeah, this basically explain whatever that I showed just now. Okay, just that because as a human, why machine learning is better in this case. As a human, yeah, I know that you can actually plot out everything by doing it one by one, but machine can do it faster. So why not you leave it to AI to help you on that? And it's more precise because there's no human error. They can make it faster, and in a sense, it's more productive to have that. So yeah, that's where basically machine learning comes in. And algorithms that we will be using just now is actually regression. So yeah, you can look at some of the examples in machine learning here, like the clustering that I mentioned just now, classifications, regressions, and yeah, today we will look into regressions more. Okay, so okay, this is one of the example we will be showing today, which is on water consumption predictions. So these are the data that falls inside, where as you can see here, the table is showing the columns of action ID, time, window duration, average. I think it's consumptions. I'm not very sure about the context already, but basically these are all of the details that comes into place when the IoT is connected to the water bottle. So it will not a water bottle, the glass. So it will calculate how much you already drink from time to time. Okay, so this is basically the data set that one of the data set that we will look into today, where this is the weight of the glass. So okay, so yeah, we can move into demo. One of the example of working with ML.NET is actually using IPYMB. So I hope you guys are here in data field. So if you know data science well, or like data related stuff well, you should know Jupyter Notebook. So you can actually run ML.NET in Jupyter Notebook. Like most of the people think that Jupyter Notebook can only run like Python, R, but actually no, it's possible to run it in here. Just that you need to install the extension of I think it's called Polyglot or something. This one .NET .NET Jupyter. Oops. I should be searching in the extension. Yeah. So this is one of the way to actually use the ML.NET API. Yeah, Polyglot notebooks. So this makes .NET possible to run in Jupyter Notebook itself, like the environment. So just to understand more about what's coming inside here, I won't run again because eventually it takes time, right? I will be showing another way of doing it as well. So okay, so basically here the first part is importing all of the packages needed to load. As you know, when you're working with, I would say most of the project, definitely you won't go with raw. You definitely will have some SDKs installed. Like if you are in Python field, you might know pip install. If you are in Node.js or TypeScript, you might know npm install. So it's something similar, just that in .NET, it's actually downloading the nugget. Yeah, so basically this is how you install packages in .NET itself. So once that is installed, then you are going to import the data into the environment. So for example, this is the data that we are using here. I just show you guys a quick glimpse of it. So it's just the same as what we have in the PowerPoint just now. Okay, the windows, I'm not sure where it's, okay. Yeah, the window duration, the weight, all of this is calculated by the IoT that is attached to the glass. And of course, here you can see, I'll share the link to this GitHub later, and I will also share the link to this as well later. I'll create another branch most likely. So basically, here is getting the data set, and then it's showing that the data set is being transferred into the code for use. So normally when you have a data set in mind and you wanted to play with it, no matter you are in you're using it in machine learning or you're just cleaning data or so on, you definitely will change it to data frame. Like no matter what kind of language you are using, yeah, you will definitely change it to a form of how the data is structured where you can actually play with it. So for this case, it's being transferred to data frame, and this is just a preview of how the data frame looks like. So basically it's just loading the CSV file and then order by time. So I think this is kind of straightforward. Okay, and so what's next is basically getting the filter of the water consumptions. Okay, so what it means here is it's taking the weight and element wise less than or equals 0, meaning that if let's say the weight is let me just show, yeah, so if the weight is less than or equals 0, it will be filtered here, and this to filter the positive and negative. I will explain why they are doing this later on. So this package itself, Plotly, is, I think it's widely used in Python. Python is pretty famous there, but .NET, there are actually supports from Plotly as well. Basically, Plotly is for you to plot graph. Okay, so it's very straightforward, or charts. So this is a display of, because when you are doing some data science project, right, you definitely need to know more. You need to understand more about your data. So most of the time what people do is after they import the data set, they will actually plot some graphs to see what is actually happening in the data. So for example here, once that is done, this is just to understand the context of the weight and also the correlations of it with the time. So as you can see here, once it's plotted, the water consumptions means the one that is in negative, and the one that that the water is not being drink. So this is how it looks like. So once you see this, like it's very, you can understand that the data is correct, because when it comes to the point that we're Okay, I'm back. My Wi-Fi has issue. I think your screen freeze. Where would I like when I get cuts off? Okay, it's okay. I continue back. You guys can notify me if I have already passed that. So basically, I was explaining about outliers, or after that is done. Can I get some help? Like where were I about the plot? Oh, they were like way above. You mean when I was explaining Plotly? Okay, shit. Okay, so all right, cool. So Plotly is a library that's being widely used, especially in Pythons, and the library has supports in C# as well, which is in .NET. So when you are having this kind of data projects, right, you will need to explore more. You need to understand more about your data. So once you have that understanding, you can actually implement what comes after. So in this case, this part of it is just checking on the charts and find for like understand more about the data. So you can see here the refills has higher weight and the water consumption has lowest weight, which is logically correct. So by having all of these steps is just to identify that, and also by looking at all of these things, right, you can actually find for outliers. So outliers are data that you don't want to include in your training data for the machine learning models, or let's say you are doing data analysis, you will definitely wanted to remove the outliers because it will affect how you do the storytelling according to the plots that you have. So what are outliers? Okay, so outliers normally how people identify that is they will use box plot, which is like this. Okay, so as you can see here, oh, I think someone might loadings. Okay, cool. Okay, so basically, according to here, you can see that in the box plot, this is where you can see the upper fence, the QT with the quarter three, and the median, the quarter one, and also the lower fence. And the one that falls outside are the outliers that you actually wanted to remove because it will actually affect how the data that is trained to the models and how the result is being predicted accordingly. So these are data that you wanted to remove. So this is one of the way to identify outliers and why you actually need to do some plotting before you have your machine learning data running, and also let's say you are doing analysis. So these are things that you wanted to take note. So basically here he's still discovering how the data works here, and also the plotting to see each of the features. As you can see here, they are actually using like different features. Features is basically the label, the column name. So I wanted to explain what is features here. So features are the columns that you think that is actually needed for the predictions later on. So for example, let's say we are finding for a house. So for the house, maybe there is some features like the house name, maybe, okay, like house address, and we have the distance to MRT station. Okay, so as you can see here, and of course there's a price for you to work with it for the data set. So as you can see here, the address and the house name is not relevant to the part of the training, because you wouldn't say that, okay, this house is named let's say APU, right? This house is named APU, it will affect how the price actually turns out. It wouldn't. The things that will actually affect is like distance. So that are actually considered as a feature, which means that the columns that is relevant to your data training and your machine learning models is actually a features that is needed to be done. So yeah, this is basically still figuring out what is data that we are working with, and so how does it looks like. So after that is done, this is where I would say more like data cleaning is going on. And also known as this data transforming, because you are changing how the data was to make it available for your machine learning trainings. So here they are using machine learning SDK, or you can understand for the .NET C# libraries here. So ML, very straightforward. Auto ML is what falls under the ML library, and it's for models that are already available and it's already built inside of the SDK. Then you can use it directly. So you don't need to do the models algorithm from scratch. You can just use whatever that is there. So it's initializing the machine learning context, and these are some data cleanings. As you can see here, this function itself is to remove columns. So what are the columns that are not relevant? It will be removed accordingly. So let's say the time, the window durations. Of course, these are the relevant one for you to identify the water consumption, right? So the weight, I would say, is like the one that you wanted to know, and then these are the things that is identified by the IoT that attached to the glass. So basically here are still the cleaning part, and once you are clean, you wanted to see everything is working fine. So you have the data frame printed up. And previously the Windows duration is in like, I think it's a time format or something. Let me just see. Yeah, it's in time format. So this one is like 3 seconds, right? 6 seconds. Now you want it to be more feasible. As you know, machine learnings are basically statistical calculations, okay, arithmetic calculations. So you really want the data to be available for the calculations itself. And even just something out of the context, if you are working with machine learning on like LLM or natural language processing, they are actually converting the sentence or each of the characters. They vector it into numbers for it to be available for the training of the algorithm. You guys can understand more by searching on, I think it's SVM or something, which is kind of widely used on natural language processing, like how the characters can actually becomes into numbers. So yeah, let's come back to this. So now it's in the training process already. Once the data is clean, you can work with data training. To build a machine learning models, you will go through an iteration of the same process. Okay, you need to identify the data sets. You need to get out the data sets, and that once that is done, okay, you need to prepare the training data and the testing data. So for the data sets that you collected, you split it into a portion to the training data and a portion for the testing. Okay, so in this case, for the training data that actually lets the machine learning learns, they are not familiar to the testing data that they have. So this testing data is very crucial for you to understand how accurate is your training data. Like, is the training data portions good enough for the models, and how accurate is the predictions? So after having that preparation, you will go through a process of understanding the data and go through a process of choosing the algorithms that is relevant. Of course, in this case, it's very straightforward to say that we are going to use regressions, because there's like a plots. You can already imagine that once the numbers is being plotted out, it will be having certain lines in the middle that you can go with. So uh, that is basically regressions itself, which is what we are covering. Of course, when it comes to the point that, let's say, okay, chatbot, right? There are multiple decision trees you can go with, or like classifications you can go with. It really depends on your data set and also your outcome that you are looking forward to have. So these are the process of creating or developing a machine learning models. So basically the iteration is from getting the data set, then training, testing, get the most accurate algorithms, then deployment, which is the one that is used for predictions. So if that is not good, you will rotate back to the first step, and it will be an iteration of it, which is also relevant to how ChatGPT is being trained, which I think nowadays is not very accurate anymore, because they are using a lot of synthetic text to train it, which is the data that is generated by ChatGPT, then they use it to train it again. So somewhat is when you are going for some specific things, you might not get it like nowadays. I'm not sure about 3.5 because I only have access to 3.0. Yeah. So okay, back to the context here. This is the train data test sets. As you can see, this is basically splitting it to the training data and the testing data. And by having that, this is where you get the features. Okay, you understand. I already explained what is features. So features are columns that is relevant to your machine learning, where it really affects the end result of it. Okay, so these are the features that is relevant as of the discovery that will be done. And here is basically creating a pipeline of the data, not data, it's already in the machine learning part. So this pipeline is how the machine learning will convert the data that you have. You can understand more by reading it, but I wanted to cover it by 10 p.m. So I will go pretty quick. I will share the link as well later, so don't worry. Okay, so this is where once you already define the pipeline, how the data is being trained to build the models, then you can work with some experiment. Then once that is done, you have the transformer, the model, so you identify which is the best model. And yeah, this is the best model as of the testing itself. And here you can actually see the predictions. So as you understand just now, we have training data that is used to train the models. So basically you are giving them some learning materials in a sense. And the testing data is like the one that you are giving them assessment. So this is where the testing data falls in. So by using the testing data, you can see that these are the original numbers and these are the predicted numbers. And the difference is basically how far is it the predicted from the actual. And by having all of these, you can actually count the percentage of how accurate is your model. So in this case, it's actually 83%, 83.886. So it's like 84% how accurate is the model is according to the testing data. So which is pretty good. And sometimes not if the model is giving like 99%, is not really good because it might be overfitting. So there's a concept of underfitting and overfitting when it comes to machine learning. Okay, so underfitting is basically you are giving not enough training data. So the models, as like let's say the model is a human, right? Let's say you are giving a human at maths. Okay, you're giving them to learn at maths, but you are not giving them the whole chapters. You are giving like the first chapter only, but you want them to answer the first to the 12 chapters, which this will cause underfitting, where there are not enough data for the human to understand. Okay, for the models to understand. And for overfitting is basically you are giving too specific and too many like same context. For example, if I tell you every day Azure is the best, Azure is the best, and somewhat you will form a mindset of saying, okay, Azure is the best. Next time if I'm going for cloud services, I will consider Azure first. So these are some of the bias that you need to take in mind when you are building your machine learning models. So that is basically underfitting and overfitting scenario. Okay, and here is basically getting the evaluations. So yeah, these are somewhat the similar items that is being displayed here is just to identify how good is your models. Okay, and yeah, this is just saving the model into a models.zip. So this is one of the way of playing with ml.net, right? And that's another ways. If you have Visual Studio, I think most of you wouldn't have it because it's kind of heavy. I'll just show you how you can play with it if let's say you wanted to create a machine learning, but it's available in code, like not just in Jupyter Notebook, right? Because eventually what I was debugging just now is this one. Okay, so I wanted to show you in a GUI manner how does it looks like, but I think somehow the web API doesn't work. Okay, so for example, right? For example, I I I open a new project. Okay, I open a new project. This is the Blazor app. So Blazor is a technology where it introduced WebAssembly. So it's just writing .NET C sharps in a website. Okay, so you're writing C sharp in website. So that's basically what Blazor is offering. And we wouldn't go deep in this because today we are focusing on ML.NET. And then now let's say you wanted to create a machine learning. It's very easy here. Okay, so you just right click on the projects here. Okay, then you click on add. So once you hover to add, you can see there's options called machine learning model. It's just very easy by using Visual Studio. And understand that if you're using Mac, the Visual Studio is deprecating soon. So there is a ways to download it, but you need to download it through Founders Hub. You can find for Microsoft Startup Founders Hub. There's a place for you to download the 2022 version in DMG format, which on Mac. So okay, back to the context here. Once you click on machine learning, these are all of the options that are available. Let's say you want to build Angular app in Visual Studio, that's possible as well. But today we are going to look into ML.NET. So you can name your configurations of the file for the ML model. But for me, I think I will keep it to the base of it. Okay. So once that is done, it will appears with a menu where today we will be going with value predictions. Okay. So these are some of the algorithms that are already available, and of course you can go with a more customized one, but these are some of the one that is already available in the ML.NET builder itself. So today we are going with value predictions, which just now we have covered water consumptions. This one I will cover predictions on diamond. So for the data set itself, I got it from Kaggle. Okay. Of course, you can play with any data. I will show you guys how does the data looks like. So there is a okay, carrot, and how's the cut looks like? Is it ideal, premium, good, and what is the color of it, and the clarity? I assume is somewhat like a categorization, and the depth, and table, the price, the XYZ, like how long is it, right? So these are the data that we have here, where as you can see, price is definitely what we are predicting. And for features, XYZ is definitely there. Table, depth, clarity, color, cut, caret, everything is useful except for the index in the beginning. So how do we actually apply it in here? So once you click on value predictions, okay, and you can choose other options if you have like Azure or like you have GPU attached, but you can read more when you click here. Okay, but eventually today's I will just demo because it will take time if I wait everyone to have the Visual Studio to be available. So yeah, that's basically why I am just doing demo, but I will share all of the code later. Okay, so the file is here. You can definitely attach it to SQL Server, but I think there is still some bug there. They are still resolving it if you are not wrong. So in this case, you are going with a file. You can use .csv file, .tsv file, .txt. So just something out of the context. CSV is basically comma separated. So as you can see in the data just now, it's like after the comma is the next value, after the comma is next value. And TSV is tab separated. So each of the values are being separated by tab. And TXT, I think most of you know, is basically just a plain text file. Okay. So by having that, say we are going to get the data in. Okay. and it will show a preview of how the data looks like. Okay, so there are like 53,000 rows here, and here is the important part for you to actually tells your machine or tells the model what you are actually expecting. So columns to predict, I wanted to predict the price definitely, and you can click on advanced data options, and this is where you can actually select like which are not the features, and is the data type correct. Okay, and of course you have data formattings as well. If like in this case we actually have a column header, so it's yes, and it's comma separated, so it's correct, and decimal dot. Yeah, this is basically how the configurations looks like by default, but you can change it accordingly to your data set that you have. And now we are going to change it here. So the index is definitely not useful, so we will swipe it to ignore. And correct is a feature, card feature. And of course, if you wanted to change this, it's possible as well. There are like Boolean, string, and single available. Okay, and then correct card feature string. I think color we can make it into categorical, and clarity categorical, and depth is a number. So yeah, single, table feature single, price is a label because that is what we wanted to have, and XYZ is a feature. So once that is correct, you can just click on save and then proceed with the next step. So what it comes here is there's a place where you can tell Visual Studio how long you wanted to train the models. Okay, so for my case, since it's just a demo purpose, I will just train it for 10 seconds. So you can see how does the training works below as well. So it is testing all of the algorithms that is available inside of the ML.NET package. And these are all the metrics that comes into place when once it's tested, it finds out that okay, this having an R square, this having absolute loss of how many values. So if you want to know more about how does a machine learning algorithm is identified as a good one, you can actually see all of these metrics. Yeah. So yeah, this is the metrics that are available for regressions. And if you are using like clustering or other things, it will be different metrics. So this is how you can identify which is the best algorithm you can go with. And then as of the summary, you can see it's a regression and the label is price and how long it's being tested. And these are the top 5. And once that is done, it's identified that this is the best model. So the ML.NET will help you to actually choose the best one that comes out of it. And this is basically a training result. Yeah. So R-squared, they have like 97% accuracy, and training time is 7.2 seconds, and models explore 22. So yeah, these are some of the metrics you can see. And once that is done, you can actually test your model. So yeah, the results is here. And let's say I have a 0.5 carat diamond, and this card is a premium one, and the color is E. I'm not sure about the context of what E is and the SI2, so I wouldn't change. And let's say it's 51.5, and table all remains at the same one. So let's say we predict this one, you actually provide a value. So it's like 581 USD for this specific diamond. Okay, so how do you actually use it? You can click on consume. So if you are using it in just for a code snippet way, this is how you can fit in. So ML model input, these are the inputs that we have previously in the evaluate. You can change it according to, like, if let's say you have front end, right, you can change it according to user input and show it accordingly. And of course, this is prediction. And let's say you already have a front end, okay? You just want something that can connect to it. You can use web API. And of course, if you just want a CLI view, you can create a console app, okay? So in this case, we will be creating a web API. so it's available to connect to it. But I think there's some bug just now when I'm trying it. So I'll just show you guys how does it looks like with that process. Okay. So if let's say you already closed this and you still wanted to change something, you just need to find for the ml-model.mb config, then it will provide a GUI for you to play with it. Okay, so it's pretty straightforward as well. Okay, let me save. Okay, so this is the web API that is built, and you can look at the code here. By default, it will create it will import all of the models SDKs of the package that is needed, and it will configure the apps. And of course, this is just referring the ML models that we just trained. So once the training is done, right, by default it will generate a ML model.zip for you, where it is where all of your algorithms and all of the machine learning context is in. It's been stored everything in the zip, because you can click inside to see what's in it. And there's a schema, the training info. Yeah, you can look at the items here if you wanted to know more, right? And of course, this is like a high level concepts of how it looks like in the code. So Swagger here is basically SDK that is available for you to create a page where you can try it out, or else by default it actually has a /predict path for you to play with it. I don't think it is working for my side, but I will just run for you to see how you can play with it. I didn't get it resolved because I'm not sure what's the issue, honestly. Yeah. So basically it's running now for the web API, and you can look at the, let me see, properties. Yeah, inside properties there's launch settings. If you wanted to see what is the pods that is on, like now the machine learning models is running on, which is on this pod, so you can play with it around. And I'll just show you if you wanted to do a front end and connect it with it. So I think I need to open two page. Let me just open another one where I can show the this is just some I don't think you can run two server on the same page itself. So basically you need to run in another window. So for this one, we are going to run the Blazor app, which is where our front end is. It's also written in C#. So yeah, would you like to continue? I think I will run this and it didn't save my code just now. Okay, so eventually the things that I want to show is actually here, but it's showing counter. Check. Let me check. Yeah, this is not the code that I have. Okay, let me find it back. Just want to give you some context of how to actually make a working one. I didn't get the time to debug it. So yeah, basically it's here. Okay, let me just run this again.
Yeah.
Someone wanted to ask something, or? And of course, if you have any questions, you just pin it in the chat so I can answer later on as well. Okay. Yeah. Okay. So once this is run, it should run a page. Yeah. So this is just front end, right? And this is where the core APIs works, but it doesn't work for now. Okay, you can see the console, it says that, oh yeah, I need to change the ports, but I don't think it will, wait, 63734, I think is correct. This is where my API is working, and the launch 63, oh no, it's wrong. So let's say I change it to this. Hopefully it's working. And in the code itself, okay, I will just explain how do you do the connections to it. Blazor call. Okay, so let's say I stop and I run again. Okay, does it work? And this is not the page. Okay, call API, run this. Yeah, it's not working. Showing me the error. But logically, how does it work, right? As you know, just now there's options like it's actually teaching you how you can use the machine learning models that you have. This is one of the way, but now you have already changed it to the web API. It's slightly different, but the context is just the same. So this is a JSON format, right? So in web dev, most of the things on the web is being passed in JSON format because it's easier for JavaScript and so on to actually render it. So how does it work here? In the button, you can see just now I have a call API button, right? It will trigger the get data options, the get data function. And this function, I created a payload of saying how many carat and how many X, Y, Z. And of course, you can do a form view for user to insert instead of you having everything hard code behind. And once that JSON payload is there with the values, I pass it to this port, which is where my predictions goes with. And this is a web API that we run on another page. Okay. So with that predictions, I passed in the values that I wanted to predict, and it's supposed to give me back the result. Okay, but in this case, I'm getting error. So yeah, somehow there are some issues here. But I will just share the code if someone managed to like fix that before me, and you guys can share it to me. Basically, that's this is the second way of creating ML.NET relevance projects, or else you can actually use Visual Studio Code to do it, but you will need some extensions to work with it. But I'm not sure now is it still working. There's like I would say more like a open source extensions built by friends here. So it's just triggering the shortcuts like control shift. Let me see. Basically here so you just type the go to, then find for ml.net or something, but I don't think I have it here. Yeah, I don't think I have it here. Yeah, I haven't installed. So this is another way of having it, but the process is actually just the same as you are using here. And here is even better because that is just like CLI integrations, but here is like GUI. You can see the whole thing. The only thing is you need to install Visual Studio and some dependencies, which you can actually check here if you wanted to try it on your own, right? Okay, so Visual Studio installer, and you find for your installer that is available on your laptop. So click on modify, and then this is just for you to find for the things. Yeah, these are all of the SDKs that are available. For my version, it's 2022. If you are downloading the new one, it's 2024. If I'm not wrong. Then you just need to find for the ml.net is being downloaded, or else you need to check and you click like install while downloading, or there's some options of on saying like install now. Yeah, download all and install. Yeah. So yeah, that's basically the sharing, the demo that I have today. And of course, if you have any questions, you can ask right now. Yeah, because basically the event's already ended. I will share the code later. I will attach it to Luma so you guys can get it. And for whoever that still in here, it's actually quite a lot, 52. So you are available to join the raffle. You are eligible to join it, the LinkedIn Premium raffle, and of course I will send out the certificate through email. Yeah. So other than that, is there any questions that you have in mind? I want to ask me. Could you explain again why there is two HTML provided for API? What do you mean by that? Two HTML provided, you mean I need to run two projects to do that. I don't really get the questions, but if you are asking that, right, because the machine learning models that you built just now, okay, is actually in another project. So that's why you actually needed to run a web API, which is serving as a somewhat like a backend. Okay, so this backend that you hosted, it can be connected to the front end code that you have. That's also commonly used in most of the industry projects. They will definitely have a front end framework and a back end framework. They need to host each of it independently, but connect it together through the API calls and stuff. Yeah, if you're asking that. Yeah, 2 HTTP. Yes. So basically, you need to run a backend so you can understand the machine learning ML.NET project that is actually running a backend server, okay, and the front end is running another server. So to have that connections together, you actually need to host both of it together, because the ML.NET project is in another files, and yeah, so basically that's why you need to have 2 HTTP. Hope that answers. Any more questions? I think I will put this call until 9:40. Then yeah, then we can close it up if there's no more questions. Yes. Correct. Yeah. And of course, if you have any questions about maybe the Microsoft Learn Student Ambassador program, or you wanted to know more about ML.NET or .NET itself, because I didn't cover a lot on the ASP.NET end, which is on the Blazor part, but it's kind of straightforward as well, like how the codes works in writing C# for a web service browser. It's just that you can assume that this is your HTML, right, and this is just your JavaScript, like normally how you work with all the JavaScript framework and stuff. Yeah. And of course, this is more like a component based stuff, because you see I can actually declare a nav menu and main layout, how does it works, and I can replace the body according to the path that I have. Yeah. Okay. Any more questions? So basically today we learn how to do it in a Polyglot notebook, which is in Jupyter, Jupyter notebook itself, and also another way of doing it in Visual Studio, which is the way that I prefer more, because there will be lesser bugs you face if you're using that way. Yeah, because it's more stable. And so one of the reasons why I recommend that is, you can see here I actually install quite a lot of the .NET runtime. This is like if you are install like Python 3.9, Python 3.8, you can actually have everything installed in Visual Studio by just running the installer and download accordingly. Yeah. Okay. I guess there's no more questions. Yeah. I will share it in the Luma later. So I attach it as a new post. Can L.NET be used in the field of cybersecurity? I think this really depends on what is the data set that you have and how streamlined you want the process to be. Because as you can see now, the process, if let's say you are doing it locally, you actually need to download the batch of the data down locally and run it there. But there are possibilities that you can have the live data running on Azure Cloud. So running on Azure Cloud, you run a VM, then the VM have the data, you have the data stored somewhere live, where it's being, let's say you're using Azure Cosmos, which is a database service. Then you connect it to your ML.NET code, and because it's running in live, right? You're hosting publicly available, is like deployed. So that is possible by using that use case. For example, I assume if let's say you are doing like cybersecurity, maybe you are storing the logs of your cloud and see is there any anomaly. You can actually work with that. Yeah. Honestly speaking, if you are doing like machine learning, any field is relevant. Just that do you have data set to play with it? Yeah. Hope that answers. Yep. Okay. Any more questions before we end? Or else we will be ending at 9:40. Yeah. Okay. And once again, the GitHub link, I will post it in Luma. Okay. Yeah. I will need to push the projects that I have here as well. Okay. Right, cool. Then I guess we can wrap up, and thanks for attending because tomorrow is holiday. If me, I will be chilling with my phone and stuff, right? So yeah, thanks for attending. Hope you learned something out of it.
Thank you, sir.
Right, thank you.